Okay, welcome back to another episode on the project. All right, so now that we're back, we've got the little bit of disaster going on over here that you saw in the last episode. It's been around a week or so. I've been doing a lot of head scratching, a little bit of CAD work, trying to get this sorted out. But I thought I would just take you all for a quick tour on some of the problems that we faced with this particular suspension system. So I did some Googling around and found a few pages of blogs of people that have put up information on issues that they've had with very similar looking suspensions to this one. So something from the Corvette C4 or C5 family, maybe even C6, who knows. At any rate, but issues with, in essence, hot rod parts that are made to improve the handling characteristics of muscle cars and other cars that didn't handle very well at the start, that the Pro Touring crowd and others have then adopted as being improvements to their particular cars, and no doubt they are. But some of these are surfacing that are having issues with respect to adjustability and geometries and being out of square and all the same things that we're facing here today in the shop. So I thought I would just take you for a quick tour on what I've been up to here for the last week or so. It's not that I haven't done all this at least once or twice before on this particular suspension, but we will be covering in this episode how I'm going to fix it. So I've got a plan, right? I always be worried of an old guy with a beard and a plan. So anyway, let's get started covering it. So what we found out from last time, and I showed you with the measurements, was these bottom brackets are pinched in. So they're a machine part, but they're no longer square to anything. And everything else in here I found was just a little bit off. So now I'm just going to take you over and we'll have a little look-see at what we're facing here. Now what I did initially in order to satisfy myself that I wasn't losing my mind when I did this was I set it back up on the jig. So I'm just going to move it down a bit. Set it back up on the jig, get this into full frame here, and very carefully set. Now I know the top of my H-beam isn't perfect, but it's not bad. But I set it up very carefully so that from this reference plane, again, from this 2x2 frame that we're using as a jig for everything, this has become the reference plane from which all the measurements that I've made are taken. I know this point on the lower control arm is supposed to be 8 inches off the ground, so I've set this as close as I can, shims and things, to getting this to 8 inches off the ground. So I've got that set. Then I've gone ahead and mapped, or remapped, because this isn't the first time I've done it on this suspension, I've remapped all of these suspension points. So the points that are critical to have the suspension work properly are going to be the lower control arm mount, okay, and because that then defines the pivot for the lower control arm. So currently we have this side is sitting cockeyed, so it's sitting in this way. Then the top here, the upper control arm and its mount. So the mount points here, the pivot point for that is going to be in the center of this bushing, right? So I've located all of these points. I've located the points where it bolts onto the part that attaches to the frame. I've basically gone ahead and located and remapped all of these points. I've had to attach this very firmly to the H-beam because it's twisted ever so slightly. So ideally we'd like to have these arms level and we'd like to have them straight. These ones were tilted and definitely not straight. Then once I put all that together remember I built these brackets, these upper control arm mounts, because the engineering report that I got, it indicated that if I moved it back, then my suspension geometry improved. So we went with that improvement. We also didn't want as much anti-dive on that arm, so we wanted the pivot points to come down a little bit. Okay, so this is obviously a modified bracket. That apparently maps more or less to what the original car was supposed to be, or at least that's what I was assured by the person who built this particular cross member. Now I've got a set of drawings, some technical drawings from early C4 Corvettes, and they actually map a lot closer to this bracket that we drew. And that, I don't know how that was done, but it's incorrect. There's way too much anti-dive on this. There's several degrees more here than there is here. So that's not going to be helpful. Okay, so what I did initially then was to re-equip all of the frame just as a grounding exercise. I put it right back to what I received. Okay, so right back to, that is the original part right here. This is the original upright part here. It doesn't fit this frame rail. Again, it was designed for a different application than I'm currently using it in. So yeah, that was never going to work anyway. I've got it just attached here with a magnet, and then I've taken the pivot points as they were originally mapped. So these two bolt hole points that locate the two pivot points for the upper control arm, I've mapped the lower control arm, and then we've compared all of it. And one thing that I learned when I did this was not only do we have the problem here with the lower control arm, we also have a problem with how centered this is. And it's not actually the frame rail to frame rail. So if I set that frame rail there and that frame rail there, if I measure that distance between the frame rails and I compare that to where the distances are in everything else, it doesn't sit square in the car. So it was sitting over to one side by almost 1/4 of an inch, which is not insignificant. Again, I'm sure all that is some allowance for production tolerances. I'm trying to build a car that doesn't have production style tolerances. I'd like to build it so that, you know, it's reasonably accurate. Back. So what I've done here is I just scribed a line 2 inches above the frame rail, and I've added just a piece of material simply to check for clearances, and then I've moved the suspension through a little bit of travel here, and I have to hold that upper control arm so it'll move nicely. But anyways, we moved it from the start position here. Okay, so there we have, that's level on the lower control arm. And you can see here, this is definitely going to represent a tight spot for us on this, as the frame rail is going to have to, come up here. The frame rail will no longer be down there. So as we come down, right, so we're going to come down. I was able to get, until it was going to foul the area, I was able to get, so right about there. I mean, go a little further and she touches, so we don't really want to go there. You can see it now. There's your tight spot right here. Now it's to the inside of this and level with this, but that's approximately where this rail normally will turn down, and I'm sure I'm not going to be able to move that location. So that's our tight spot. I've only got, in this case, about 2 inches of droop travel. Suspension design says 3 is what we're after here. It's simple enough to get. All I'm going to have, if we went down 1/2 inch, right, which we can easily measure here and then scribe a new line. If I go down, reattach my plate here, I know it hangs out a ways before it goes down in the design, and then I just double check the front and back edge of that. It's level enough for this kind of work. Okay, now can I get, and holding on to that, I think 1.5 inches is going to be golden. I'm all out of jack travel here as much as anything. And the suspension is now, it's almost at a full 3 inches of droop, almost. And we're still a finger away here. We'd be at 4 inches of droop probably before I'm going to run into anything I would consider to constitute a problem. In fact, level that off a bit better. If I can get this jack just to That's all she's got, Captain. Here we have a quick model of the new front cross member. It's not perfectly scaled, actually. I didn't scale where the uprights were. This is just a model that I made in order to draw these two particular parts, but I've completed it just so we can have a quick look at what we're about to get into here. So in the next section, while I'm waiting for some other parts to get cut, I thought we would whip it around here. I thought we'd just take a quick look at how I've already gone ahead and built. This is the lower control arm component here. So I'm just going to show you how I made that particular component in the next little section of video. We'll move on in further videos to show these uprights and the other associated parts that are actually going to comprise the rest of the build. So there it is in all its 3D CAD glory. To show you the parts that I'm going to make. Now my CAD foo is not really all that good, but here we are in Fusion 360. I've created a couple of the component parts. So you've already seen me cut these out. This is that piece of 1.5" square tubing that we're using. And then these are the pieces of round 1.5" 100 thou wall or 120 wall. So we're going to use those. Anyways, these are the steps. Basically, this is how this works. I have no idea if this is going to work, but I figured I usually go a little bit too quickly and I don't always explain exactly what I'm doing. But on these parts, what we're going to do is we're going to put a hole through the middle of here, and then we're going to array those bushings on top. Not really bushings, but the round parts. We're going to array those on top. Okay, so first, let's just do this. As we're going to do this, we'll select a face. I'm going to draw my tool. There's no chance my hole saw is going to be able to actually be 1.5" around, and I'm actually counting on that. I need it to be just that little bit bigger. Anyways, and now we're going to just move that. And there's a distance that I need to be about that. And then I need this distance here. To be somewhere about in the middle of the part, or well, exactly in the middle of the part. Okay, so with that, we should be able to get this all to work. So we now have placed that on top, and we're just going to fake drill it as if we knew what we were doing. So that's because I've radiused the edges there, it gives me that little bit of a chamfer. But imagine we're going to go, sorry, it'd be helpful if we went to the negative side. I'm not trying to grow something out of it, I'm trying to punch something through it. Okay, so that should give me the punch through for these two separate parts here. So that's what would happen, or what will happen when we drill it, is we'll cut the edges of it. And then we should be able to get those other parts to go straight in to these parts. So this is sort of the way I work when I think this out. I don't normally do this in CAD, but and I'll just create, don't worry about how I have to do that, but now I can select the entire component. If I want, I can move it to wherever I want to move it. Let's just slide this one over and put them up there. And if I'm super clever, I can get the rotate out of it too today. I don't want to take too much time with this, but you get the idea of what we're going to do here. Is, of course, we can grab this one as well, and we'll just rotate it up, and we can take the other components. And this is stressful because I have to see if I can remember how to do all of these fun things. It's reasonably new for me to figure this out. Actually, I want to do this differently, but there's a 0 chance that's going to work right, but you get the idea. It's always in the wrong place, whatever you do. But at any rate, I'll get that to there, and I actually do know how to do the correct move. I don't have time right now, so I'll slide that back along, and there. Okay, so that's going to be the part that we're going to try to make when we're done. That's fine. It's just asking me to be smart. Oh, we're not quite done. Anyway, we'll slide that back just a bit more, and that's the part that we need. So I must have shifted that while I was playing around. Okay, so that's the part that we need, is that one, this one here. Okay, so we're going to go ahead now and make that part. Yeah, whenever I see this thing throwing sparks like that, I always get a little bit worried. It's like, it's time to get that blade sharpened, and you can have them sharpened. I have a local guy who sharpens them up for me. You get a few hundred cuts out of these dry cut saws, by the way, if you're interested. Now I'm setting up for the round part to get cut off here. You know, if this was a fancy YouTube channel, we'd go ahead and part it off in a lathe that we own, but I only have a saw. Funny, I can get these things reasonably accurate if I'm really careful with the measurements, as you see me just endlessly setting it up, and then, you know, don't breathe, just carefully, don't move it. Anyway, and then we cut it off, and then I tried to fast cut all the rest of these so you didn't see that the switch doesn't work. The switch has never worked. It didn't work right when the first day I got that saw, but I also haven't. I've had the saw for 7 years, and I haven't made any move to fixing the switch yet. So it's it's part of the charm of that particular tool. Anyway, we'll get 4 of these cut, and then we're gonna run them over to the grinder, where I usually just take the saw marks off and then put a little chamfer on. These are gonna be a TIG welded part. So I'd like to get a little chamfer in there just for weld prep. Make sure everything's clean. I don't think I showed any of those steps, but whenever you're working with this kind of material, you have to make sure that you thoroughly clean the outside edges of it. Kind of oils and whatever comes out of the processing of the tube. The round parts are drawn over mandrels with DOM tube. The other parts are just a hot rolled structural steel, and make sure if you're going to TIG weld this stuff that you get rid of that. So you have to get rid of all the mill scale off of it to weld it effectively. So instead of getting real bluing, I'm just using my Sharpie there, just cheating. Putting a couple of scribe lines on so I can find the exact middle of the part. So we're pretty pleased with that. Scribe those in there. And over to the drill press. So I don't know if this is the right way. I've just always sort of done it this way. But first, when I bought the drill press, I bought it specifically to find one that could spin slowly enough to effectively turn these hole saws. You can see there in the clamp setup that I've put 2 aluminum blocks on either side of the jaws, and that's because obviously the CAD's already shown us that we're probably going to cut through the edge, and I just don't want the hole saw actually hitting the hardened jaws of the vise So I've centered it, just a little pilot hole there, centered where I want it exactly. And then I've got a welding clamp and clamp that down. I mean, how else are you going to keep this in a centered position? So here we go, drilling our hole. Sorry for the noise here, it's always terrible. I try to have it. Obviously I can tighten those belts up just a little bit more because there's a little slippage now and again. You just sort of get used to the pace of your own hole saws as you're going. Here we go, almost all the way through. Thank goodness for video editing. A little bit of cutting oil always makes things go better. Here we're just about done. Last little bit. Now I take it really slow because of course I'm taking that partial cut all the way down the wall of the tube, so there's no point in rushing that at any point. So here we are, we got it out. Just like the CAD drawing, hey? Can't get any better than that. I'm super happy. A little spool out of that. Alright, so it's a little deburr here. So first with the die grinder. Wow, that's a terrible noise. Sorry about that. But here's the die grinder just buffing off the edges. Again, we're going to have to TIG weld those, so give them a little weld prep, make sure everything's nice and clean. Get the insides too. I've had lots of, you know, until you've done it a few times, you don't learn to clean your parts properly, but clean the insides of those. Anyways, there they are, all done. Thanks for tuning in. Oh yeah, please like and subscribe.